In this video, I am going to discuss how to multiply two matrices. Before we continue, let me explain the notation I use in this video. A is our matrix. Now we write it like this, and here we specify U cross V. This one, U cross V, we call this the type of the matrix. Here U stands for the number of rows of the matrix and V stands for number of columns of the matrix. Then any element in this matrix we represent using simple A. Since this is capital A, we use simple A, I, comma J. Here I means the row number and J means the column number. Therefore, now let's write the elements in the first row of the matrix. Here A, row number is 1. Column number is 1. This is the first element in the first row. Now second element of the first row, row number is 1, column number is 2. Likewise, we can write the elements. The last element of the first row, A, row number is 1. Since there are V number of columns, we can write down I, comma V. Now let's write the elements. In the second row, here A, row number is 2, column number is 1. This is the first element of the second row. Then here row number is 2, column number is 2. This is the second element of the second row. Likewise, the last element of the second row we can write 2, comma V. In this way, we can write down the rows. So now let's consider the last row of the matrix. Here A, since there are U number of rows, here U, row number is U, column number 1. This is the first element of the last row, U2. This is the second element of the last row, and we can continue like this. This is the last element, of the last row. This is the notation I use, and now let's discuss how to multiply two matrices. We have one matrix like this, the other matrix like this. So order is important. Therefore, this is our first matrix and This is the second matrix. From left to right, this is the first one and this is the second one. Here we, let's say the type of the first matrix is M cross P. That means there are M number of rows and P number of columns. Now, in order to be able to multiply these two matrices, the type of the second matrix must be P cross something. In other words, number of columns of the first matrix must be equal to the number of rows of the second matrix in order to be able to multiply the two matrices. Otherwise, multiplication is not defined. So, let's take the number of columns of the second matrix is n. Now, multiplication is defined. So, in the resultant matrix, there are m number of rows and n number of columns. So, now M cross N. So let's name this matrix as matrix A, this one as B and this one as C. Now we have in this matrix there are M into N number of elements. If you consider one particular element, we can represent this using simple C I comma J. Here I means 1, 2 up to M. J means 1, 2 up to N. Let's try to understand how to compute Ci comma J. In order to compute Ci comma J, now the position of Ci comma J in this matrix, it is in the ith row and in jth column. If you consider Ci comma J element, it is in the ith row and jth column. So, in order to compute the value of this, we have to consider the ith row of the first matrix. Now here, in this matrix, we have to consider the ith row, and in the second matrix, we have to consider the jth column. Now, I will write down the ith row of the first matrix. So here A I comma 1, A I comma 2. In this way we have up to A I comma P. Since there are P number of columns, number of elements in the ith row is P. So here we have P. This is the ith row the elements in the j column of the second matrix. Here B 1 comma j, this is the first element in the j column. So second element is 2 comma j. Likewise we have B. Since there are p number of rows in this matrix, here we have B comma j. This is the j column of the second matrix. J column of the second matrix. Now, in order to compute C I comma j, we have to multiply first element by the first element of this row by the first element of this column, second element of this row by the second element of this column. Likewise, now if you consider there are p number of elements, since there are p columns in this matrix. Now there are p number of elements in this column, since there are p number of rows in this matrix. Therefore, we can multiply A I comma 1 to B 1 comma j plus A I comma 2 into B 2 comma j plus the last elements A I comma P into B P comma J. So this is how we can compute C I comma J element. If we use sigma notation, we can write down this like this. R, let's take R. R goes from 1 to simple P, A, I comma R into B, R comma J. So now I hope you can understand the multiplication of two matrices. After that I will explain 6 examples. Let's look at the first example. We have 4 2, 5, 3, 2. So we are asked to multiply these two matrices. First of all, we should check whether the multiplication is defined. So in order to do that, here we have one row and three columns. Here we have three rows and one column. These two numbers are equal. Therefore, multiplication is defined. In the resultant matrix, there are the number of rows in the resultant matrix is 1 and number of columns in the resultant matrix is 1. Therefore, we have it like this, 1 cross 1. Only one element is there. So, as usual, if we have this, let this is A, as we have discussed earlier. This is A, this is B, and this is C. Then here, this one is simple C 1, 1. Simple C 1, 1. So, in order to find 1, 1, this number 1 means in here we have to consider the first matrix. Here we have to consider the second matrix. Row number 1. Here row number 1 means this is the row. Here column number 1. Here we have column number 1. Now we have to consider this row and this column. So first element by the first element, 4 into 5 plus second element by the second element, 1 into 3. Third element by the third element, 2 into 2. 20, 23 plus 4, 27. Therefore, now here we will get 27. So now this is the answer. So let's look at the second example. I will swap the order of these two matrices. 5, 3, 2, 4, 1, 2. So first of all, we have to check whether the multiplication is defined. Here 3 rows and 1 column, 1 row and 3 columns. These two values are equal, therefore multiplication is defined. In the resultant matrix, there are 3 number of rows and there are 3 rows and 3 columns. Now here 3 rows and 3 columns. So Now, if this is our matrix C, now altogether 3 into 3, there are 9 elements. C1, 1, C1, 2, C1, 3. C2, 1, C2, 2, C2, 3. C3, 1, C3, 2, C3, 3. So now let's try to find C1, 1. In order to find this, in the first matrix, row number 1. In the second matrix, column number 1. So in this row we have only one element. In this column we have only one element. Therefore 5 into 4, 20. Now the answer is 20 here. Now we have to find C1, 2 here. In the first matrix, row number 1. In the second matrix, column number 2. Five into 1, 5. Therefore, here we have 5. Now if you consider C1, 3, in the first matrix, row number is 1, in the second matrix, column number is 3. Therefore 5 into 2, 10. Here we have 10. Now we have to find C2, 1 here in the first matrix, row number 2, in the second matrix, column number 1. 3 into 4, 12. So the answer is 12. C2, 2 in the first matrix, row number 2, in the second matrix, column number 2. 3 into 1, 3. Therefore, here we have 3. C2, comma 3. In the first matrix, row number 2. In the second matrix, column number 3. 3 into 2, 6. So, here we have 6. Now C3, comma 1. In the first matrix, row number is 3. In the second matrix, column number is 1. 2, comma 4, 8. So here the answer is 8. Now C3, comma 2 means in the first matrix, row number 3. In the second matrix, column number 2. 2 into 1, 2. So here we have 2. Now we have to find C3, comma 3 in the first matrix, row number 3. In the second matrix, column number 3. 2 into 2, 4. So here the answer is 4. So now if we look at these two examples, the two matrices in this order, we got this answer. If we swap the order, we got this answer. The two answers are different. That means the order of the two matrices is important. Now let's discuss another example. So we have third example, 1, 2, 5, 3, 2, 6, 7, 4. These are the two matrices, 1, 2, 5, 3, 2, 6, 7, 4. Here first of all, we have to check whether the multiplication is defined. Therefore, here we have 2 rows and 2 columns. Here we have 2 rows and 2 columns. These two values are equal. Therefore, multiplication is defined. In the resultant matrix, there are 2 rows and 2 columns. Therefore, this one is also 2 cross 2 matrix. Now, altogether there are have to compute 4 elements. So in order to find this element, this is our first row and first column. So here we have to consider the first row in the first matrix, then first column in the second matrix. 1 into 2, 1 into 2 plus 2, 2 into 7. The answer is 16. Now let's compute this value. This is our first row and second column. Therefore, here we have to consider first row in this matrix and second column of this matrix. Therefore, 1 into 6, 6, 1 into 6, 6, 2 into 4, 8. The answer is 14. Here we have 14. Now let's find this value. This is our row number is 2, column number is 1. Therefore, we have to consider second row of this matrix and first column of this matrix. 5 into 2 plus 3 into 7. The answer is 31. Now we have to find this value. This is the second row and second column. So here we have to consider the second row and here second column. 5 into 6, 30, 3 into 4, 12. The answer is 42. Here we have 42. Now let's see. Let's swap the order of the two matrices and see. 2, 6, 7, 4. Here we have 1, 2, 5, 3. Here the order is 2 into 2 cross 2. The type is 2 cross 2. Type is 2 cross 2. As in previous situation, in the resultant matrix we have 2 cross 2. Since these two values are equal, the multiplication is defined, and in the resultant matrix there are 2 rows and 2 columns. So now, as in previous situation, we have to find 4 values. This one, first row, first column. 2 plus 11. No, sorry. First row, not 11. First row, first column. 2 plus 30. The answer is 32. Here we have 32. Now let's find this value. Then we have to consider this one and this one. 2 into 2, 4. 6 into 3, 18. 22. So here we have to consider this one, this row and this column. 7 into 1, 7 plus 20, 27. The answer is 27. Here we have to consider this row and this column. Fourteen, 12, 14, 12, 26. The answer is 26. Now look at these two examples. These two matrices in this order, we got this answer. If we swap the order, we got this answer. The two answers are different. Therefore, again I emphasize the order of the matrices is important. Now let's look at another example. Three, two, one. Five, four, three. Four, two, one. 6, 1, 3. 3, 5, 2. Now, first of all, we have to check whether multiplication is defined. Here we have 2 rows and 3 columns. 2 rows and 3 columns. Here we have 3 rows and 3 columns. Since these two values are equal, multiplication is defined. In the resultant matrix, there are 2 rows and 3 columns. 2 rows and 3 columns. We have to find so now let's find this one. We have to consider first row, first column. 3 into 4, 12, 2 into 6, 12, 1 into 3, 3. The answer is 27. Now here, this row and this column. 3 into 2, 6, 2 into 1, 1, 1 into 5, 5. Sorry, this one and this one. 3 into 2, 6, 2, sorry, here. 3 into 2, 6, 2 into 1, 2, 1 into 5, 5. 13, here we have 13. Now this element, so we have to consider this row and this column. So here 3 into 1, 3, 2 into 3, 6, 1 into 2, 2, 11. Here we have 11. Now we have to find this row and this column. 5 into 4 20, 4 into 6 24, 3 into 3 9, 53. The answer is 53. Now we have to find this one, this row and this column. 5 into 2, 10, 4 into 1, 4, 3 into 5, 15. The answer is 29. Now we have to find this. This row and this column. This row and this column. So here 5 into 1, 5, 4 into 3, 12, 3 into 2, 6. The answer is 23. The answer is 23. Now, last example. Let's swap the order of these two matrices. 4 2 1 6 1 3 3 5 2. 4 2 1 6 1 3 3 5 2. This one 3 2 1 5 4 3. So first of all, we have to check whether the multiplication is defined. Now here we have 3 rows and 3 columns. Here we have 2 rows and 3 columns. Now we have to check whether these two numbers are equal. These two numbers are not equal. Therefore, multiplication is not defined. In other words, we cannot multiply these two matrices. Okay, that is why I have always told the order of the two matrices is important. Now we have discussed 6 examples. So I hope you could understand properly matrix multiplication. Thank you for watching.